Right. Hello, everybody. Welcome to Energy Finance, and welcome to my home as well, at least to a small room or small corner of my home. So, as I said in class, the point of these videos are to just highlight the most important points in the handouts. The handouts are already posted in Moodle, so I expect you to watch these videos and then read the handouts before class. Again, I will not be talking about everything you see in the handouts, because I think it's useless to have a video just reading handouts. So I expect you to read them on your own. All right? Okay, so let's get started. Let's open the handouts. And these are the ones already posted in Moodle. The goal for today, I'm going to make this a short video. I'm just going to cover this initial chapter for the first class. All right? And since this is going to be a short video, I'm already going to show you something that I want to show throughout the small session, which is the following website. So this is an electricity market in the US. We'll talk more about what this market is later on in the course. But for now, I just want to look at what's going on here. So this has a bunch of prices, of electricity prices, and we're going to look at this price right here, the Western Hub price. Right, so now in the US, it's still early dawn, so people are not awake yet. But let's see how this goes. It's not the best time to be doing this this experiment. This is live, but let's see how it goes. So I'm going to record this price here in an Excel sheet I have here open. So it's now 11:12 here in Portugal. So time 11:12. And the price is $16.03. So I'm going to keep a list of prices here, and I'll come back to this as we move along. All right, let's go back to the handouts. All right, so basic concepts, definitions, and units. So first of all, what is the difference between energy and traditional finance? Well, first, this energy is a very wide field. There are many different areas that you see here, from oil, gas, and so on, all the way to electricity and to energy trading. And in most of the course, we'll take the view of a company that generates and sells electricity. And that is going to be, I think, useful for our course, because it allows us to integrate all these different areas of energy. And the reason is that a power company has to buy, for example, natural gas to generate electricity, and then it obviously sells the electricity it generates. So it integrates all these markets, and it can use risk management to avoid uncertainty about the prices of their inputs and their outputs. So it's a nice setup to look at all these activities. It's a nice point of view to look at all these activities, right? And as we'll see, there are significant risks in this market, and risk management will be very important, right? And that's what I'm trying to show you live here with this browser page that you can see now again here. I'm not sure if this is refreshing automatically or not. Let me try to do a refresh. Let's see. It is refreshing, but it did not move that much still. So it's 16.09, the price. I'm going to write it here, 16.09. I mean, just a couple of minutes after we took the first recording. Now it's 11:15. All right. Let's go back. Keep coming here. Okay, so what is specific about energy markets? Well, there are two types of markets, physical and financial. And the important thing here, or what is different, is that the physical markets, the properties of the actual products that we are trading, are going to be fundamental to understand how the financial markets behave, how the prices behave. Okay, so one thing we will talk a lot about is that energy is difficult and expensive to store. I mean, it's very different from a stock. If you want to store a stock, you don't even think about it. It's in your bank account somewhere. It's just an electronic record somewhere. But here it's different, obviously. I mean, if you want to store oil, you have to have a big tank to actually put the oil, the actual physical oil in. That costs money. If you want to store your electricity, that's even more complicated. There are some solutions, but in some application, it's not even yet technologically feasible to store the amount of electricity you need, right? So what does that matter? What's the issue here is that the link between spot and future prices will be different, will depend on these different ways that we can store the underlying product. So future prices for oil will be linked to spot prices in a way that is different from how electricity future prices are related to electricity spot prices, right? Other differences, time matters. As we'll see, for example, electricity at a given point in time is different, has a different behavior in terms of price than electricity during the night. I mean, and you can imagine why. I mean, during the day, in the middle of the day, everybody's awake, everybody's consuming electricity, factories are working, there's a lot of consumption. At night, everybody's asleep, so there's not that much consumption, and that will obviously influence the way prices behave. In other words, there's a lot of seasonality in these markets. Natural gas, the example you see here, and so on. So we'll talk more about this. You will see different seasonal patterns throughout the day, as I was discussing, and throughout the weekdays. The weekend is different from business days, and throughout the year, throughout the seasons of the year. Okay, we'll come back to that later on. Location matters as well. The idea here is that, again, talking about electricity again. So let me step back. So obviously, location does not matter for a stock price, right? If I ask you what is the price of Microsoft, you don't ask me, am I talking about Microsoft in the US or Microsoft somewhere else, right? There is just one price for Microsoft. Here, it's different. So there is a price for electricity in Portugal, for example, and there's a price for electricity in Spain. And furthermore, then the differences behave in a kind of predictable, to some extent, or systematic way. So under some conditions, we expect the prices to be the same. There are other conditions we expect the prices to be different. And these conditions are more or less predictable, okay? But not totally predictable. So what we'll have in electricity is that we'll have, and this is a good example of these energy markets, is that we'll have a behavior that is very different from the usual stock price behavior. So in electricity, you'll see big spikes. You know, what this means is that the price goes up a lot, and then, oops, I'm sorry, I'm just noticing that you are seeing my browser instead of my PDF. Okay, so this is the first recording, sorry for that. So since you are seeing my browser, let me see, I was just talking about prices moving, and oh, the perfect example. So these are the advantages and disadvantages of doing this in real time. Western Hub price, this was the price we were just looking at. Now it's 25.30. So let me write that in my Excel sheet here. It's 25.30, the price. and the time is 11:20. Just write this here again. Sorry, my Excel here is not behaving. All right. So there was, the last recorded price was 5 minutes ago, and the price was 16. 5 minutes after that, the price is at 25, right? So now let me open the PDF. This is where I was talking about. I was discussing how electricity prices behave, and what I was illustrating is that they have big spikes, and that a spike is pretty much what you just saw. In 5 minutes, the price went up a lot. It goes up. It spiked, and this is a spike in the sense that some time from now, some minutes or some hours, we don't know, but eventually the price will come back down to something closer to a previous level, right? So we'll keep illustrating that. All right. How are our markets organized? In these markets, in these energy markets, there are two important exchanges. We have for the US market, this one here, and for global and European markets, this one here, the ICE.com. Right, and you'll look at all these products in these exchanges in due time. Okay, one important part in this introductory class is now this definition of energy and power. Okay, so this is an energy finance class. Let's start by defining what energy is, right? So a basic definition of energy is the capacity to do work. So for example, if I want to push my screen here across the table from here to there, I need to have some energy to do this work, which is to push the monitor from here to the other side of the table, right? The amount of energy is measured in this unit, the joule, right? I mean, in this example I was just telling you, I mean, if I want to move the monitor, I need energy which comes from the cereals I ate at breakfast, and you can actually open up or look at the cereal box, and you will see there saying that that particular cereal has, I don't know, 500 calories per each amount of 100 grams, for example. So in that example, the energy was the calories I ate at breakfast that gave me the energy to move the monitor, right? So there will be many units for electricity. In that example, the unit was calories. The main unit, the standard unit that we'll use is the joule. All right, a second concept is power, right? And the power is the rate at which something uses energy, right? So we have the unit of energy, we divide it by time, and that gives us this concept of power, right? And power is measured in these units, watts, all right? So this is sometimes a bit confusing for people that are just looking at this for the first time. So one way of thinking about it is this idea that you have here. So think of energy as volume. So for example, if I have a bottle of water full of water, the volume that is inside the bottle, the amount of water, is energy, right? And then as I start pouring the bottle, the water flows out of the bottle, and think of that as power, right? So units of energy, again, the main unit is joule. Unfortunately, or fortunately, whatever, there are a dozen different units of energy, right? So as we'll go through the course, we'll talk about all the different energies. Different markets will use different units of energy. One important one that we'll want to discuss right now is this one that you have here, right? And again, this is sometimes confusing, so let's look at this slowly, right? So let's start with the 1 watt, right? So I just defined what the watt was here, what is the unit of power, and what I will do is just to scale it up. So multiply 1 watt by 1000. So 1000 watts is called a kilowatt, okay? Kilo stands for 1000. Again, I told you that the watt was a unit of power, meaning that it is what? It is energy divided by time. So what I'm going to do is something weird. So I'm going to take this side here, and I'm going to multiply this whole thing by time, right? So you can see if I multiply on this side by time after this, the time cancels with this time. This is seconds, so if I multiply by number of seconds, this would cancel. And so I would be left with joules, with energy, right? So what I'm saying is that if I multiply power, watts, by time, which is the same as multiplying on this side, the time cancels and I'm left with energy. So that's what this unit here does. I start with power in watts, scaled up by 1000, but power. I multiply it by time, by hours, and the result, power times time, becomes a measure of energy. So what you have on the left-hand side, the kilowatt hour, is a measure of energy. Again, this is confusing because I just told you that watt was a measure of power, but this is not a watt, this is a watt hour, which becomes a unit of energy, right? So exactly how much energy? So 1 kilowatt hour is 1 kilowatt. What this actually means is 1 kilowatt times 1 hour. 1 kilowatt is 1000 watts. A watt is a joule per second. How many seconds do we have in an hour? Well, an hour is 60 minutes times 60 seconds. 60 times 60, 3600 seconds. So this times this gives me 3,600,000. And again, joules per second times second. The second cancels with this second, and I get just joules, which was our basic measure of energy. Okay, so the kilowatt hour is a measure of energy. To make this simpler to read, instead of writing this big number, what we write is this number here, 3.6 megajoules. M stands for mega, which is 1 million. All right. So then you have here some examples. Go through these examples, and we will talk about this in class if you have any questions. Right? Let me just go back to the market. Let me show you the Western hubs. Oh, how is this doing now? Refresh the page just to make sure. $22.13. So let me write here 22.13, and now it's 11.29. Right. So I can actually show you my Excel file here. So these are the prices that we have been looking at. Again, this type of behavior, it's typical of electricity markets. I'm going to stop the video soon, so we're not going to keep going through this. But I mean, if you look at this market later on in the day, or if you do this on your own throughout the day, going through the market at different points in time, you will see that these jumps will happen almost every day. And I have seen days where I remember days some time ago where the initial price was at 40, and in a couple of minutes it jumped to 400. So 10 times higher, and then it came back to 40 within another few minutes. So it's really a very volatile market, and that's interesting if you like risk management, and this is the environment where you really need to be worried about volatility and risk. All right, so going back to the PDF handouts. These are the exercises you have at the end of the chapter. these exercises I recommend you do. The solutions are at the end of these notes. And then I will post the first assignment that will ask you to do similar types of exercises. All right, see you in class. Bye.